So next in this video, we're going to be talking about functions, again, different ways of um, represent a function, and also how to find the domain and range of those functions. So the first way to represent a function, as we mentioned in the previous section, is to basically create a diagram and connect members from domain with members from range. And so with this representation, domain and range are clearly labeled. So domain is in this cloud and range values are in this cloud. There is no work involved at all. The next way to represent a function is by ordered pairs. Okay, so here, if we want to identify our domain and range, then we have to do some work. And remember, what we're going to do here, they asked us to find the domain of this function. And since this is not a continuous line, these are just disconnected points, and therefore we cannot write the domain as an interval here. Okay, we're just the domain would be just point values, separate values, 2, 3, 4, 5, 6. And when you were to draw or to graph this function, you would just have a set, like I mentioned, of disconnected points. So the interval notation does not work here. The interval notation is for continuous intervals, where you include all the values in between your points, your big end point and beginning point. Not in this case. So for this case, we're going to use a set notation. We're going to say domain and just list them in a figure bracket. So we open the figure bracket and list 2, 3, so 2, 3, 4, 5, and 6. That's it. That's all that we have, and close that figure brace. That's all. That's how you would indicate the domain for this function. So again, for this type of function, you cannot use interval notation. You cannot use a set builder notation. All you can do is just list the values as a set. Well, I guess it is a set builder notation. So, but you cannot use inequalities. Okay, so not inequalities, not interval, just a set. Now I want you to go ahead and try and list the domain of this function using set notation. Again, that should be easy, and we'll come back in a couple of seconds. I want you to pause the video here. Okay, so I assume that everything is clear with when you have only points, when the function is defined as a set of points. Now the question is, how do you find your domain of the function when you have an equation and not a set of points? Now you're going to ask yourself, what kind of values can I substitute for x? So that's your question. What kind of values can I substitute for x? And if you're unsure, even you can create a table for x and f of x. Can I put in 0 and then put it into the function, process it, and get a meaningful answer? And the answer here is yes. What about a negative value like -2? What about a positive value 3? What about a fraction? And you may want to try all of these numbers. What about the radical? Can I put in a rational number like maybe pi or square root of 3? Is it going to work in my equation? Can I put it in the calculator even and get a value for f of x? And if your answer is yes, I can put in any of x values and it's gonna work in my equation. I'm gonna actually find the corresponding y value. Then your answer here for the domain, x can be any real number, real number. And so, and if that's your conclusion that x can be any real number, then you're gonna write your use your notation such that we looked up in the previous video. So this is the slide that I was showing earlier. And so if you have the domain where it's all real numbers, you can either use this R notation for set builder notation, or you could use interval notation and say that your domain is from -infinity to +infinity. So those are your options. So here we're going to say domain from -infinity to +infinity. Here they didn't tell us what kind of notation they want us to use, so I chose an interval notation. Now I want you to take a look at this function and also think about what would be the domain of this function, what kind of x values are appropriate or would work in this equation. And I assume that you already did that and figured it out. So our next example is finding the domain of the function involving denominators. Actually, let me summarize what we found first. So in the first example, this function is a polynomial function, which only has variable x involved to different powers and maybe multiplied by some constants. And usually those kind of functions, they have a domain that is all real numbers. Now we have another common function which has a denominator. Now usually for a function like that, your domain is not going to be all real numbers, because remember, we cannot divide by 0. So when we're talking about the domain of this function, then the values that turn your denominator into 0 do not work. So we have to exclude values that turn your denominator into 0. So basically you set it equal to 0 on purpose and figure out which x does that. What is the solution to this equation? Which x will turn 2 minus x into 0? And this is a no-brainer. I hope that it's easy for you to solve this kind of an equation. So we said x equals to 2. That value will turn your denominator into 0. So we need to exclude it. We exclude x equals 2 from the domain. Okay, so what does it look like? Domain. So what does it look like? Here's our number line, here's our 2, and we have a open circle by 2, meaning that we're taking it out. Now, everything else to the right of 2 and to the left of 2 works as an x value, but not 2. So how do we write it? In in inequality notation, it's going to be x could be greater than 2, so going to the right, or it could be less than 2, going to the left, either or. Now, how do we write it in interval notation? Well, we have this 2, it's basically divides our line into 2 pieces, 2 intervals. One is from negative infinity up to 2, and we have a square not square, round parenthesis here by 2, and then we get over 2, jump over it, and then we continue on. So the second interval is from 2 to positive infinity. Here it is, and again, round parenthesis by both endpoints. Joined by our unity symbol, which translates as or. So I want you to look at this example and let me know, what do you think? What would be the domain for this function? Again, as a reminder, your numerator could be anything. We don't care about what numerator is. It's allowed to be 0. The only thing that worries us is when we have a 0 in the denominator. So only denominator cannot be 0. Numerator equals 0 is okay. Pause here, and we're going to continue in a second. So the next type of a function where you may be asked for domain is a square root function. Okay, so let's talk about the domain for the square root function. As a reminder about radical functions, we cannot take square roots of a negative number and get a real number as the answer. So for example, if you were to take a square root of -1, it is not a real number. It is an imaginary number, which we're going to be talking about a little bit later in the course, but for now, it's not a real number, right? So we cannot have a negative value under the square root. Same goes for any negative number, not just for -1. Now the question is, are we allowed to have a 0 under the root? I'll give you a second to answer that question. And hopefully you said, you answered yes, and square root of 0 is 0. Why? Because 0 squared is 0. So remember, the definition of the square root is square root of a number a is a number b such that if you square b, you get a. That's the definition of the square root function. So, and the reason that square root of -1 is not a real number, because we cannot think of a number such that when squared will give you -1, right? There is no such number. That's no such real number. That's when squared will give you a -1. So basically, that's the basis for our domain of the radical function. So basically, we want this value under the root be greater or equal to 0 always. So 5 plus 2x should be greater or equal to 0. So that's how you set it up. And once you solve this inequality, you're going to have your domain for this function. So for which x values 5 plus 2x is greater or equal to 0? Let's go ahead and solve it. Subtract 5 on both sides. We have 2x is greater or equal to -5, and then divide both sides by 2 will give us x is greater or equal to -5/2. And by the way, when you subtract a number, you don't switch the sign. When you subtract or add a negative number, you don't switch the sign. You only switch the inequality sign when you divide or multiply by a negative number. So this is our answer in inequality form. This is our domain, right? So x is such that x is greater or equal to -5/2. And in interval notation, that would be from -5/2 to positive infinity, including -5/2 and not including infinity. So this is what it's going to look like. And as usual, I would like you to try this problem. Again, find the domain of the radical function f of x equals square root of 7 minus x. Go ahead and let me know how it went. Another way to present a function is by graphing the graph of the function. And in this case, the domain, we already mentioned that before in 3.1, it's basically the horizontal stretch. So where's on the x-axis, if you travel on the x-axis from left to right, where does your function begin and where does it end? And for the range, it's basically a vertical scan. So a vertical stretch of the function. Where does it, how low does it go and how far up does it go? So that's your range. And like we mentioned before, there could be gaps in both the domain and range of those functions. For example, the domain of this function, again, the domain is x value. So if we travel along the x, this is the first time that we see a function. So it's negative. It starts with -3, and then we go forward. And since we have an arrow here, that means this function continues indefinitely down and to the right. So on the right side is going to be infinity. So domain is from -3 to infinity. And because there is an open circle by -3, that means we're not including that point and we're not including infinity. Now for the range. So I want you to stop for a second here and also think of what the range would be. Pause here. And I will assume that you already answered the question. So the range, the range is from the lowest to the highest point of the function. So the lowest would be -infinity because it continues indefinitely on this side. And the highest point is right here at y equals 0. There is no function above it. So y equals 0 is the last point. Now, this is an interesting case because y equals 0, the function comes up to this level twice. Once here, and this point is not included, and once there, and that point is included. So we are going to include 0 because it touches 0 at least once. Okay, so in including 0 endpoint. Now, here's one real world, let's say, problem or data um, that you may see. Just for an example, it says find the domain and range of the function whose graph is shown. And what do we have here? We have energy information, um, the Alaska crude oil production, and on the x-axis we have years, and on the y-axis the oil production in barrels, thousands of barrels per day. All right, so how would you approach this problem? So, of course, the oil production was going on before 1975 and after 2005 as well. However, this is the only information that we have available to us. So we're not going to assume that it goes on beyond we're not going to extrapolate beyond the points that we have and or the years that we have. So we're going to say that our domain is basically between 1974 approximately and 2006. So one of the rules of statistics, do not extrapolate your data beyond what you have. So we don't have any information beyond this. So we're gonna just stick with these values, the ones that you see on the x-axis. Now, what do we have on the y-axis? The range. Think probably the lowest point would be about 100, and the highest point would be 2000. So for the y it would be 100 to 2000. It's 2006. All right, and again, this is inequality notation. You could use interval notation, set builder notation. I won't bore you with that right now. And I want you to try this problem right now. And again, pause here and answer the question. Let me know if you have any questions or problems.